here. We're doing a joint talk about cloud native, or Java cloud native. I'm doing a piece about how JVMs are evolving to deal with new cloud native workloads.
And I'm going to be talking about how application servers and the APIs they provide are evolving for cloud native Java workloads.
It's going to be exciting.
It is. Very exciting.
So between us, we provide variations of the software that you probably use in your day job if you're producing Java applications, microservices, whatever. You'll have some app server and you have some VM. Right? So this talk is about cloud native Java. So I'm going to talk a bit about the runtimes, not too long, and then Graham's going to talk a lot more about the app servers because there's more to discuss in that space. And we've tried to do this to be engaging, so that means you get to participate. So I hope you like the pizza. So you've been developing this Java application for years. It's your baby. It's this big monolithic thing, right? And you get told, you're told to move your monolith to the cloud, to a cloud native program. Do you? Decide cloud native is so different, you should just start again. Right? Who'd do that? Who, given the monolith that they might own or have owned in the past, would chuck it away and start again? Yes, okay. One good, one right answer there. Okay, who would decide that cloud native is going to go away? Right, and the cloud is going to die, and soon it'll be spending more money in data centers, and you'll get that big desktop on your desk like you wanted, one of the big Mac Pro things. Who thinks the cloud is going away? Good, right answer. Do you understand how modern Java runtimes let you reuse and extend what you have? Do you want to go to a talk to understand what's happening to VM in the application space so that you can take some of the stuff that you've written and move it and change it and modify it and possibly learn how the cloud is going to change the way you think and some of the other aspects? Yes. You're all here, so you voted for that one. Right. So, I'm going to quickly talk about economics. Okay? Very quickly. So, I'm not going to use the word too much. What's special about cloud? Why do we even care? Why has it got its own word? And the reason is for a whole bunch of characteristics that you know about, but I've written down, so it makes me the expert. Right? So virtual, dynamic, infinite, scalable, always available, all those great things, and more than anything, it's minimal upfront, no capital expense. Lots of people like that. You're just spending expense, you're just spending dollars to buy something for as long as you need it, and then you give it back. Okay? Take your code, run it on somebody else's kit, don't worry about it, pay for what you use, and give it away, and then sort of use it. Okay? Compute on demand, compute on tap. It's what we've always wanted. We've been promising the world that that was going to happen, and now it has. And we're now all deep to the armpits in cloud. So here's the rub. Cloud computing changes the way that we think about computing. Compute equals money. It was always true because we bought stuff as big pieces of metal and they went to the data center. But now we're buying things from the cloud, right? We're hiring them. We're not keeping them, they're not ours, we're just borrowing them for fun. So suddenly what we borrow, what we buy, is all based on what the financial agreement is. CPU time, gigabytes of RAM, disk space, bandwidth. We're buying those things. So suddenly what your application consumes is directly connected to the money you spend. Right? It's closer. People can think about it. So people, i.e. accountants, look much harder at where you spend your money in the cloud because they understand money. And when you say, I want another big computer in the cloud, they go, I know how much that's going to cost. They get it. Right? So they take that equation. Compute equals money. The big one is this one. This is the one that pretty much all of us get hit by. Gigabytes per hour. Wherever you're buying something in the cloud, the chances are you're buying RAM. tend not to buy so much big CPUs. Those are obviously their options. The thing that always gets us is how much RAM are you buying? How many gigabytes per hour have you bought? And as a Java developer, that means this. Right? This is your new life. You may not have internalized this yet, but as a cloud, if you're putting Java in the cloud, that is your new life. What does that mean? It means when you change your dependency and you add that latest widget that you can, or the next version of something from Maven, and your memory requirements go up because that's they're doing something cool, and now you have to add 10% to your MX, whereas before you could get away with it. Now your accountant's going, excuse me, why's the bill gone up? Oh, by the way, you're running multiple microservices, so why has it gone up n times? So it's yucky. And let's look at this in more detail. So, time, demand. We know all about that, right? So you would put something in the cloud, you have some workload, peaks and troughs. Okay. How would you deal with that if you were doing that as a traditional process? You'd buy a big box, and you'd scale the big box to cover the biggest peak of your expected workload over the whatever period, the year or 5 years, wouldn't you? What happens if you do this in the cloud? Well, every bit above this white line where you haven't got the demand to make use of all this extra resource you bought is wasted money. Okay, everything above the white line is money that you could have saved. So what do? Well, you guys know what we do. What you do this thing. You break it into smaller units. Because smaller units, you can scale smaller units to fit under the curve. And in fact, you can do this. Hey, microservices. Here is the fundamental reason we do microservices. Because the ability to scale the pieces that we need in a cost-effective manner. Other reasons, but that's the biggest thing. We still end up spending more money than we'd like to, but we still have that model. Okay? Okay, so all this got to do with Java. So you pick any one of these little boxes, you pick up your monolith or whatever, what does the profile look like? If you're doing any sort of Java benchmark, if you've looked on the web, you'll see Java benchmarks that have that sort of white line curve. Right? So time, memory, or throughput. So basically what happens is it takes time for your thing that you've deployed to reach maximum capability to handle a workload. Right? The red line shows you that it takes time. We all know, you've got to create things, the JITs have got to get in there, the memory's got to get working. That's all this sort of takes time to get that. Okay? And in the meantime, your memory usage tends to peak. You tend to go over, you tend to go up, and then a bit later on you come down. And that's a really classic sign for Java profiles. You look at them, they always look something like that. And in the cloud, that's a problem. Because the longer it takes your microservice to be effective, that means there's another microservice you've deployed, possibly on standby, to deal with that workload. Right? So the longer it takes to get ready, the more you've got to have knocking around, the more you've provisioned them just in case, they're costing you money. And this line, imagine, well, you know this, you're deploying something on Amazon, you pick some tier of machine. Imagine the scenario where you have to pick the tier above just to get your microservice to start, because you end up with this peak of memory usage that gets claimed back eventually, but it is too late because you've had to buy here when you could have bought here. So the cloud says, none of that please, we want this shape. Okay? So put that in words, what does cloud say? Cloud says, memory footprint as small as possible please, we can't waste memory. Small deployment sizes, more to do with bandwidth and stuff like that, but it's related. really fast starting applications. And, though don't need to talk about it now, if you're a cloud provider, one of the things you really want to do is have VMs and other deployment mechanisms that give back things when they're no longer using it. And you'd be surprised how often applications and runtimes hold on to things that they could give back. But we won't talk about that now. So, can we do this with the JVM? Can we give you a JVM that has those characteristics? Can we match that code? Do we want to? So, new question. Is the cloud so different that a JVM is no longer relevant? Yes. Who thinks the answer is yes? Who wants to stop using their Java skills and wants to go use Node instead? Or Ruby? Okay, anybody'd like to, but doesn't want to, No? Okay. Is anybody being asked to? Oh, yeah. Don't worry, this is the answer for you. Okay. B. Maybe. But retuning the JVM, is that going to work? Can you achieve those curves by lots of retuning? Well, okay. Do you think you could do that? I think some of you are actually trying to get better performance out of your VMs by playing with all the knobs and levers. It can be fun. But the answer really is C, why I'm here. Because the answer is not all JVMs are the same. Let me introduce you to this. So OpenJ9. So I work for IBM, JVM that we have had for many a year, that our enterprise customers use, that runs on tiny devices to big devices. It's called J9. And last year we open sourced it. And we open sourced it because at the end of the day we have tech that meets these needs, and I'll show that in a sec. But if we don't share it, then we run the risk of Java becoming less of a choice. Because if we can't get Hotspot, we can't get OpenJDK and other things to make the necessary changes, right, just by talking to them, then we're all at risk. So we came down to the conclusion that the best way to help show that we can do this thing and make it available and have the conversation about what Java in the cloud should look like was by open sourcing that stuff. Right? So this is available to you now. Dual licensed if you care. Okay. Clipped for Apache. So no GPL other than what's in OpenJDK. Okay. You can go get this from Eclipse. You can download it from Adopt. So if you want a Java 8 or a Java 9 or a Java 10 or a Java 11 or a Java 12, whatever, in binary form, you can come to Adopt and get it. And if you want it with Hotspot or with OpenJ9, you can get it. Right? And the support for that is going to be there. You can buy support for sure. But if you want continuing binary availability with service, with security fixes, etc., come to Adopt. Because it's going to be there for the foreseeable future, for years and years. Right? And we're building it. These are all TCK'd, they're all available to use. Again, you can go to Adopt, you can choose Hotspot or OpenJ9, or choice. And there's even a Docker place that you can go. Adopt OpenJDK as a Docker place. You can go get Docker images with OpenJ9 in, or Hotspot, you choose. So why J9? This is what it started on. So why? Well, we bought the company that produced J9, a company called OTI, many years ago, because, as always, big companies are looking to fill in the gaps around the end. And we were looking for things in this space. But it turns out that this thing, the J9 code base, that its architecture was so good that this is what we use for everything. It's one code base that runs on the smallest machines possible, all the way up to the biggest, mainframes, clusters. It's the same code base. Okay? And the reason this works, and the reason this works for cloud really now is, you look at what you need from a small phone, small footprint, okay? Very limited RAM, fast startup, because if you're pressing, every time you press the app on your iPhone or your Android thing and it takes ages to start up, that means you go, I'm going to delete that, can't be bothered, I want instant on, okay? And you want it to be full function immediately. Those are the sorts of things you want on a phone. You want it instant on, instant running. And they are exactly the same sort of requirements that you need for the cloud, Footprint for the providers, the guys who are actually running the cloud. The more they can get on the hardware, the more money they can make. Okay. Fast startup, quick immediate ramp up, they're all the same characteristics. So, does this work? So here we are. Startup time. Take your OpenJDK, one of them, I think there's an 8, with hotspot, switch it to OpenJ9. So the same classes, the same binary, the only difference is the VM has changed. Okay, you turn shared classes on, you get quick start, you get a 30% improvement. Footprint, memory footprint, 60%. Just switch hotspot, OpenJ9. It's literally take one out, put one in. Now do it clever, and your memory footprint will go down. Because the way that we designed the architecture of the machine. So this thing, remember this? This is what we wanted. Here's a hotspot, OpenJDK now with hotspot. Basic benchmark, the usual sorts of things. Red line is throughput or memory usage. If I switch with J9 to OpenJ9, I get that. I don't get any bumps. I get a much faster startup. I get a much straighter throughput. Bear in mind, everything above this red line between here is new work that your application is able to do. And if you want to go here, there's an AOT option you can turn on, specific AOT option, which basically says do all the compilation up front, never do any jitting, and you can get almost instant on, but you can't get the same throughput because we're not doing the re-optimizations. And again, look, this space here is all more work that you could achieve rather than waiting for a hotspot to get there. Now this is us going, hey, we're here, hotspot guys, quite capable of catching up. We want to have conversations about how we make that real and how we keep pushing that so we get the right characteristics. That's why we're doing this. We have a JVM that we're sharing because we think it's got the right characteristics for the cloud now, which you can use, and it's there for us to have a conversation about where is cloud native Java going to go. So from my point of view, we're done. The JVM saves the day. We can leave now. Don't take my word for it. You can go tweet about it, and there's lots of people tweeting about it. Literally, go try it yourself, switch. If it doesn't work for you, I really like to know, because we think generally people get some improvement, usually quite enough for them to be going, oh, okay. OpenJ9, adopt OpenJDK. So, quiz. Are we done then? Yes. What's he doing there, Grant?
I don't know, the next one might do that as well.
Haven't you? Yes. So, do you think, let's go back, do you think, are we done? Who wants to leave now? All good, okay. Okay, yeah, we still need, let's do all of it. Well, yes, still need to re-architect my application. Yeah, okay, that might be true. And actually, there's more to it than just having a better VM. Okay. So, I will hand over now to Graham, who will tell you more about what you should be doing.
Okay, so Steve's talked about the JVM and all the benefits you can get by maybe picking OpenJ9 and how that helps with cloud native deployments. But that's not necessarily the whole story, because the things you run on top can then, of course, impact your deployment, your experience in the cloud. So quite often, as this says, the benefits you get from the Java runtime are far outweighed by essentially the weight of the things that you then run on that Java runtime. And probably history gives us a fairly good example of that. So I work on a Java EE capable application server. Who here uses application servers? A few people? Yeah. You still write Java EE applications, write Spring applications, so on, that kind of thing? Yeah, okay. So Java EE didn't start off big. It started off in the kind of late 90s as about, 10 specifications or so on, and towards the end of the 90s. And as requirements were based on the platform or leveraged on the platform, it grew and grew and grew. And there was a kind of realization, probably well before 2009, when we split it into profiles, that it was essentially getting too big for it to be useful for many kind of deployments. And so in E6 it was split up into web profile and full platform. But of course, all that did is said, well, kind of 80% of applications use what's in web profile, but of course whenever you talk to people they said, yeah, well, I use some of those things still, but I need one of these things that's in full platform, so I still end up having to use full platform. And of course this has continued, and we've now got EE8 with even more capabilities, and still the compliance requirement to have all those capabilities. But what vendors did, and what a number of implementations have done, is provided ways of actually picking and choosing what you use. So rather than having to use the whole of the application server environment, which in some cases can be kind of, 500 meg download or whatever, something pretty significant that uses a heck of a lot of memory when you just start it up and you haven't even got any applications deployed. Rather than that, what they've done is they've allowed you to just pick and choose the capabilities that you want. So this is Liberty, so Open Liberty, you can choose, for example, I just want to use JAX-RS and I want to use Open API, so maybe I'm writing a REST service and I then want to publish that API of that REST service using Open API. Who's familiar with Open API? Okay, a few people, yeah. Who's familiar with Swagger? Usually get more hands for Swagger. So Open API is essentially a standardization of Swagger. And if you maybe use JBoss technology, then you might be using Wildfly Swarm, or now as it's known, Thorntail. And again, it lets you pick just the capabilities you want, and it will create a custom runtime to support your application. And this again these are just the Maven build dependencies. So again, depending on JAX-RS and depending on the Swagger capability. Okay, so that's kind of showing how the kind of application server or runtime folks have kind of evolved things over time. So the JVM's evolved to support cloud-native technology, cloud-native requirements, and runtimes have evolved to be able to skinny those things down so you can produce something that's very tailored to the application or the microservice that you're deploying into your cloud environment. But not all the challenges can be actually resolved through the runtime. So we're halfway through our cloud native talk, so now I'm going to level set on what I think cloud native is. And it might be slightly different to other people's views of it, but to my mind we got to cloud native by essentially taking the M out of everything that we did, removing the kind of the heavyweight processes and the monolithic aspects of how we created software and deployed software. So it started out with Agile, and we evolved the development practices to get rid of the kind of the waterfall monolithic approach to producing software. We pushed that through into the DevOps side of things so we can now push things into production much quicker. We still had a problem with acquiring the actual stuff you wanted to deploy onto, which might be buying the stuff, but also the approval processes to get all of that. And actually what cloud does is it enables you to actually have the infrastructure on tap. And then finally we still were pushing things as monoliths out into the cloud, and actually what we needed to do is re-architect, so we had a more agile way of actually evolving the software infrastructure, and so that's where microservices come along. And so when you do this, and you're actually developing microservices, and you're doing DevOps, and you're wanting to actually build something that you then you have your unit that you're going to test and then eventually deploy into production, that raises new requirements on how you write your application and how you evolve your application. And so what a group of vendors did, and you can see the number of people involved now has grown along the bottom. You probably can't see that. But if you go to microprofile.io website, you'll see all the vendors that are actually involved in creating MicroProfile. Is they got together and said, well, we need to create a number of new APIs, a number of specifications that vendors can implement in order to support new cloud-native microservice development. And so what I'll do is I'll walk through the capabilities that are actually in Eclipse MicroProfile. Some of these, it's interesting doing this talk after Daniel, because a lot of these are about how to do things in the application. We've heard how there are use cases for when you might want to do that and when you might not. interestingly, as I was walking through these slides, and I thought I'm not going to have very much time, and I've actually got less time than I thought I was going to have. I've got just a couple of charts that talk about service meshes and the relationship with service meshes, and thankfully I left those in. So there's a good chance you're going to be writing REST APIs is the starting point. So I like to think about MicroProfile as a kind of three layers, as the kind of foundational basic things that you want to do, the kind of bread and butter or meat and potatoes or whatever you want to call it, whatever your favourite food is, maybe pizza. So you're going to be writing to write REST services. And what MicroProfile did is say there are some perfectly good technologies out there. Let's just adopt those where they exist, but if they don't exist, let's define new ones. So for example, JAX-RS for writing new REST services. If you've written REST services using the Spring APIs, JAX-RS is very, very similar. JSON-P for working with JSON objects. CDI, this is equivalent to, I guess, Spring Beans, so it gives you a component model. You can define a bean. Essentially, you can define the life cycle of that thing, and you can define what gets injected into that. So you can start wiring up your logic for your service. And then finally, there was an observation that the JAX-RS REST client capability was pretty basic and not very nice. And so MicroProfile got together and defined a type-safe REST client. This is really, really nice because it actually mirrors the way you define the REST service on the server side in terms of the programming model you use to do that. So the next layer up, well, as you go down a kind of cloud-native microservice approach, the chances are you're going to be wanting to handle large numbers, tens, maybe hundreds of collaborating services that are going to be frequently evolving. So what is the impact that has in terms of the APIs that you need to use? And you've also, when you're doing microservices, you might be moving to some kind of different development model where you have teams that are aligned with the microservices. So you then have organizational boundaries as well as API boundaries between the services. So first thing we've got here is OpenAPI. So I mentioned that it's like Swagger. Essentially, it gives you a way of defining and documenting the API, so you can publish that and describe it to someone, and so they can then, using whatever language they like, they can understand what that API is. It's in a language neutral form. They can then write their own clients to call your API. Talk about JWT, security. So you want to be able to do security flow security information between your services, and then maybe in your service be able to allow certain people who are in certain roles to call certain operations within your service and prevent others from calling them. Configuration. So I talked a little bit about DevOps. I think is it factor 11 in 12 factor, basically says build the thing once and then deploy it in many places. So you don't want to, if what you do through your DevOps pipeline, if the final thing you do before you go into production is actually rebuild the artifact that you put into production, then you're invalidating the testing that's gone on earlier on in the pipeline. So what MicroProfile config does is it allows you to inject configuration. So you can externalize the things that vary between your deployments out into configuration. And you can then define config sources that are standard config sources that are defined for certain platforms, but you can also add your own. For example, you can inject configuration from a Kubernetes config map, for example, if you're deploying into Kubernetes. And I left this one to last. So fault tolerance. So this one defines a lot of the capabilities that we just heard relating to Istio or Lyft and so on. So you can do various fault tolerance capabilities such as retries and fallbacks and got out of my head now, bulkhead and so on. The various different patterns. It implements a number of different patterns. It defines a nice simple annotation-based approach for doing it. So you just, for example, you can just add an @retry annotation on your method and say the number of times you want to retry it. You could then add an @fallback annotation. You could say I want to call this other service, or I want to call this other method within my existing service implementation as a fallback. So it's quite nice and neat and simple in terms of how it lets you do that. Oh, we're on to a quiz. So you're deploying microservices that depend on other teams' services and have noticed occasional errors from them which cause your service to fail. Do you blame the other team, because they're clearly incompetent and they need to get their act together? Do you hold firm and trust the other team that they're going to get things right eventually and you don't need to do anything about it? Or do you take responsibility and gracefully handle those service issues? So, votes for A. It's funny, Blaine gets quite a few votes whenever we present this. In fact, somebody tweeted about it when I last presented this one. Trust. Don't trust other developers, do you? Take responsibility. Yeah.
I think you should do both, A and C.
A and C. Blame that, yeah.
Parallelly.
Yeah, I need to add an option D, don't I? Which is A and C. An interesting thing, just a slight aside. So when we talk about high availability of software, we often the panacea is 5 nines availability, which I think equates to 5 minutes and 26 seconds. I was looking at it just before. Downtime in a year, which is pretty darn small. Or if you go for 4 nines, then it's 52 minutes and 6 seconds. And interestingly, if you've got a monolith that has 5 nines, and then you break that up into 10 microservices, and the first microservice calls the second, and so on. And so when you do an invocation, it then goes through all 10 microservices. If each of those has 5 nines availability, then actually your availability drops down to 4 nines. And if it goes through 100, it drops down to 3 nines. And so that has a big impact on your availability. So doing something like this is kind of very important if high availability is critical. Okay, so the last layer. So again, Daniel talked a little bit about some of these capabilities. So handling hundreds of collaborating services requires strong operations focus. How do you know what's going on, and how, if something goes wrong, where's it gone wrong? Or can you actually predict that something's going to go wrong and take action before it actually does? And so what MicroProfile does, I really need to align these boxes, no OCD there, is what it does is it defines 3 APIs. So there's open tracing, which lets you essentially handle the tracing of requests through the microservice calls. So this will handle the header stuff that Daniel was talking about. Health check. So what health check does is it basically says the health. So Kubernetes has this notion of readiness or liveness probes, which says, is this thing alive and is it ready to accept work? But that, whether you're healthy or not is not necessarily known just by the container. It's quite often an application decision. So for example, or a microservice decision. If I have a microservice that depends on 3 other services, maybe I can still be healthy and still function if 2 of those services are available and the 3rd one isn't. And so health check, what health check lets you do is it lets you define what the healthiness is of your microservice, and then it provides a REST API for you to then go and visit, and it will tell you whether that service is up or down. And then you can then point, if you're deploying into Kubernetes, you can point your liveness or readiness probes at that health check endpoint, and then that will report it back to Kubernetes, and Kubernetes can respond appropriately. Last one is metrics. So understanding what's going on inside your microservice in terms of what's your JVM doing, how's its heap behaving, what's the garbage collector doing, understanding what the server runtime is doing, and any information you can get out of the server runtime. And then lastly, what's your application doing? So letting your application define metrics. And so what this does is it produces standard metrics, but then it lets you define application metrics on top, and then you can go and visit that REST endpoint, get those metrics out, and it produces them in a JSON format, and I can't remember the name of it now. Oh well, it'll come to me later on, probably when I'm on my second Guinness or something.
XML?
No, it's a really ugly format, but it's a particular tool that accepts that format. Anyway. Alright, quiz. So, you're about to be the proud owner of a live production microservice, and you like your weekends and want to minimize time spent resolving issues. Do you A, decide it's a no-op due to encapsulation? The great thing about microservices is you never need to know what's going on inside. Votes for that? Don't we believe in encapsulation? Write everything to standard out. That's what factor 11 of 12 factor tells you to do. Problem solved. Got to vote for that.
I've seen people do it.
Yep. Okay, see. Instrument your service for health and with Kubernetes probes and metrics for Prometheus. That's the format I was after. Should have just waited, shouldn't I? And use open tracing / zipkin or whatever you want to use under there to track request flows. Excellent. All right. Can't we all do this with the service? Do all this with the service mesh? Well, a lot of it you can, yeah. But I think we've seen examples, or I've mentioned examples such as metrics and health, and some of the open tracing stuff. You want some help from the runtime to be able to do those things. One of the obvious ones is fault tolerance. And yeah, so what we do, for example, in Open Liberty is let you switch off most of the fault tolerance capabilities. We think fallback isn't something that Istio understands, for example, and also it's quite often an application concern. So doing fallback within your application still applies, but we let you switch off the other things so you can actually use Istio to do those kinds of capabilities. One of the things we're actually looking at is to let you write in MicroProfile fault tolerance, essentially what you might consider the default behavior, and then have that configure Istio as a starting point. So build a better relationship or a closer relationship between MicroProfile and Istio. All right, packaging for deployment. How are we doing? Got 1 minute. 3 minutes. You're going to be generous to me. Thank you. I'm going to largely skip this, other than to say one thing to be aware of. So we talk about, quite often in the Java world, we talk about fat jars or thin walls, and I hear that fat jar is the answer to everything. Okay. If you're building Docker and deploying in Docker, it's very important if you want your Docker deployments to be, or need to optimize your Docker deployments, then what you want is to layer your Docker images appropriately. Have your layers be the least frequently changing things at the bottom, most frequently changing things at the top, and ideally the things at the top are the smallest. Because what Docker does is it will cache things for you. And so if you're rapidly changing your application, you don't want your application server or your frameworks and libraries and things to all be pulled down every time, because they're actually packaged inside your application in the fat jar world. And so this is just a kind of thing to keep an eye on, is make sure you layer things appropriately. And actually what we've done just recently in Open Liberty, for example, is provided a tool that lets you take this, but then shred it apart appropriately for a Docker image. So you start out with a fat jar, but you can create a Docker deployment. I think this works very well with the kind of Cloud Foundry build pack, as was mentioned earlier. Okay, your boss asks you to recommend a technology stack for developing and deploying cloud-native microservices. Do you recommend Eclipse OpenJ9?
Yeah.
Oh. Do you recommend Eclipse MicroProfile?
Yes.
Louder?
Definitely.
Do you recommend a right-sizable runtime with a broad open spec support? Perhaps this one. Optimizing deployments for cloud. Or all of the above. Okay, that's all I had. We got some useful links. I used all my extra 2 minutes, almost.
Thank you very much.
Thank you.